But y'all should have got the meter certification if you came through the program. So these are the charts, and these will be on the test. These are what we call function charts and also step sequence charts. All the ones except for the tech generators that we just looked at, those are not up there. But I'll try to do that. So Siemens teaches what we call a system level troubleshooting class, which basically, and that's what this is. So you learn how the system operates. You learn about the sensors. You don't necessarily know how they electronically do what they do. All you learn is what are they supposed to do. Because the environment that we're in now, if a sensor doesn't do what it's supposed to do, you don't fix the sensor. All you do, you replace it. You know. So to get an idea of an automated system, what's nice about an automated system is it goes through a sequence, right? So this occurs first. This is required to cause this to happen. This is required to cause that to happen. This is what's required to cause that to happen. So if you understand the sequence, then you should be able to fix the thing if it does what? If it stops. Of course, we already know what sensors do, right? Okay. Everybody okay on the sensors. So what do sensors do? What do electrical sensors do? Take something physical and converts it over into something electrical, right? You understand that? So what we're going to do is, so y'all not going to work on this station. We'll look at this station and figure out what it does. And then, yeah, this is module 1. This is the one we'll look at and see how to set up this sequence chart. And so first thing we need to do is we need to be able to identify what's what, right? So we know this belongs to actuator 1, right? Because it's 1A. So if we see A, it means it's an actuator. And what does an actuator do? Turns energy into motion, right? Of course, we're using either pneumatic energy or electrical energy. So we have a lot of pneumatic actuators over there, but we also have a lot of motors and solenoids and stuff like that. Sensors are labeled 1B1, so this shows us this double action cylinder, and then it shows us where all the sensors are. So this is the magazine that we put the blocks in. So right up under that magazine is B1, right? You see it? So if we looked under there, and I think I showed y'all, that's the parts present sensor, right? And then if B1 is present, then we'll start getting in sequence. So first of all, before anything happens, B1's got to be true, right? Well, that's not really true. What should happen first? Well, first thing we should be able to turn the power on, turn on the outputs, and then what do? We cycle it between what? Okay. And then on this one, you'll have to hit the start button. After that, the whole thing's automated, unless we have it in what we call single step. So what's nice about this manufacturing line is you have the ability to put it in manual, and you're going to single step it. So this is what we'll do when we set up this sequence. We'll do what? We'll step it, right? And then step it and step it and try to figure out what has to be true. Of course, we know what's got to be true here before this thing will extend. What's got to be true? Well, we know this sensor down here at the bottom's got to be true, right? So we know B1's got to be true, right? And also 1B1 has to be true, which indicates the what? That the cylinder is what? Retracted. So those two things have got to be true before we do anything, right? You understand And then, of course, we got the Traverse, or we got the gantry robot. A gantry robot is a robot that is overhead. It actually runs overhead. So here's all our sensors. We have a flow control valve, right? We already talked about those. And then we have a Hall effect. So they call this a Hall effect, 1B1 and 1B2. So what does these two sensors do for us? Y'all recognize the picture, right? This is the robot. The gantry robot that feeds the pick and place station over to the other station.
But it has the block.
Not quite yet. This indicates these guys are up here on this pneumatic cylinder. So 1B1 would indicate when it's retracted. 3B1 would indicate when it's extended, right? And then they don't show it right here. You don't see it right here, but we have a 4B2, which indicates it's all the way on the right, and then we got another one over here that they don't show it, unfortunately, that shows when it's on the left, right? So before we extend this thing down, what's got to be true? Well, we know that this guy right here's got to be true, and it's got to be the carriage has got to be all the way on the left, right? Everybody okay? This makes sense. And then we got to have a part that's put out. So we got to look at this. So when this guy right here extends, 2B2 goes true. And now this guy right here knows that there's a part, right? You understand, before he can do what? Before he can extend down. Everybody follow this up? And then, of course, so if a part is if this guy here is extended, which means there's a part present, right? Because it wouldn't extend it if there wasn't a part there. Everybody okay? Then that tells this guy, and this guy's retracted. Now it should be able to do what? To send this thing down. And then when it's fully extended, how do we know? How does it know when it's fully extended? Because 3B2 becomes true, right? 3B2 becomes true. Everybody follow this? So when 3B2 becomes true, right? What's it going to do now? Should turn on the vacuum. And then it's got a sensor that indicates if the vacuum is present. But that's the other side of the line, right? Everybody okay? So this is showing us the parts. So we know here's our Hall effect sensors here, right? And then we can't see the Hall effects over here. This is the B1 is up under this, and it's pointing straight up. It's a diffuse sensor, so it's pointing up straight up and reflecting off the line. And we talked about the vacuum generator, right? Yeah, we actually went over and showed y'all the pressure switch that's on the vacuum line. How does it know it's generating a vacuum?
Yeah, what did he read?
It's a vacuum switch. Well, it's not. It's a pressure switch. Because if it's coming out the suction cup and blowing straight out, because it's not on it, it's sucking in, it's not up against anything, right? Then it won't be able to generate pressure. Okay. Y'all understand that? How can we get a vacuum from a pressure? A vacuum from a pressure. So this uses, both the lines use what they call a Venturi, a vacuum generator. Well, sort of. How does an airplane fly? How does it create lift? So y'all don't know how an airplane flies. Really? Y'all really don't? Y'all haven't ever heard this before? Well, what happens is that we enter air into the front of the airfoil, which is the wing. A wing is an airfoil. And if you ever looked at the wing, you'll notice you'll notice that it's what? You know it's curved on the top and flat on the bottom. So what happens is your air comes up and hits this. This flows over the top, and so this starts moving real fast. So the faster moving air creates a vacuum, which causes low pressure. And then the bottom one comes over here. It's moving straight, so it generates a high pressure. So it going over the top of that wing, that curve over the wing creates a low pressure. On the bottom, we have a what? A high pressure, and creates lift. So if we can speed the air up through a orifice, then we can create a vacuum. So a Ventura sensor comes down here, narrows down, goes over like this, comes back up, and comes like that. And then the other side looks basically like this. And then when the air comes through, what's it got to do? It's got to flow through that, and it speeds up going through here and creates a vacuum. So we put a little tap right there, and now we got a what? We got a vacuum. And this is what a Ventura vacuum generator does. So what we do is we take pressure from our compressor. Our compressor don't create a vacuum, it creates a pressure, right? You understand? But we run it through the Ventura vacuum generator, and it generates that low pressure. We use this all the time, guys. Anybody got a pressure washer? You can get you got a tub on the front of it. Why don't the water squirt up the tub? Because it runs through a little Ventura and creates a vacuum. So if you put soap up in the top, what would it do? It'll just suck it right down in there and add it to your water. So anybody's got a pressure washer, basically all of them have that plastic tank on it that you can add soap and stuff to, right? So anytime we speed things up, then the pressure is going to go down, right? You understand? And we use that all the time. Airplanes, that's the way they fly. It always amazes me that you got them wings out there that creates enough lift to do what? Pick up all of you. And that the wings are the only thing that's technically generating the what? The lift. The wings on the U-2, I don't know if you ever seen a U-2 fly before. It was one of our first flight ones. Those wings are so long and they're so thin that they flop down. And when the planes, and they literally put little wheels out on the very end, and they'll have a Jeep in there behind it. And when it's trying to take off, it'll take, because it's only got two wheels down the center of the plane. And the two wheels that's out on the wings, they're just propped up under there. And you can see the wings come up, and then these things go bouncing down the runway, and the Jeep comes up and does what? Picks them up. And then the U-2's fixing to land, it's coming down, and this Jeep's right behind it, right? You understand? And the pilot comes in, brings it down, and they'll jump out and hold the wings up until so U-2 is a neat airplane. So this is the way our vacuum generator works. Well, the problem is if we let this air come through here and do like that, then it's not going to be able to generate a pressure, right? You understand? So that's the way the pressure switch works. The pressure switch is sitting right up here. So it's sensing the what? The pressure, not the vacuum, but if until the suction comes down and locks onto something, then so we're using a pressure switch, but the pressure switch is sensing what? When the vacuum is made. And it happens every once in a while, the little vacuum cup, which is like this, will literally come up and it'll flip up like this. And it won't generate a vacuum. It'll just sit there and go, right? And we have to bring it back up and flop it back down because it's very palatable, I'll say. Huh? Well, it depends if you take care of them. If you come up here and jerk on them and stuff, we've had, of course, we've had the Festo line since we've had the Festo line since 2006. And so, yeah, it eventually gets wore out. But if you ever notice, they just screw in pretty easy. So, in fact, we've got one on the Festo line over there. We had one where it wouldn't pick up the blocks. And we thought that it was the suction cup because it had a little nick in it, but it wasn't that. But somebody had turned the pressure down on the regulator. And of course, the pressure was turned out of the regulator and it wouldn't generate enough vacuum to pick up the block. So that's the way airplanes fly. So the Ventura works on exactly the same principles that airplanes do. So once we learn the sequence, I'll get it up here in a minute. Let me find my other PowerPoint because I couldn't get it to come up on my computer, so we're watching it remotely. Feed cylinder, pickup cylinder, right? Vacuum suction cup, vacuum generator, valve body position, so it's out, right? Okay. So I think we'll have the actual procedure here in a second. So this is where we're starting out. So what's got to be true before we start everything? One B1's got to be true. I don't remember if it's got to be true. It's got to be what? True, and then of course the one we can't see is the one that indicates that it's on the left. If all those are true, then what's going to happen? It's going to send out the block, right? Vacuum off, cylinder this, and we're on the left position. If all this is true, then what happens? Send out the block, right? Now, how does it know the block's okay? Well, now all of a sudden, this guy right here comes on, which says it's what? It's fully extended, right? Okay. So what's going to happen? Fully extended, right? That light is on, right? Valve body's in place. So what's going to happen? And it's going to go down, and it's going to, how does it know it's down? So this is still true, this is still true, this is still true. I'm sorry, this one goes false, this goes true. No, it knows it's fully extended. So what's it going to do now? Turn on the vacuum, right? You understand that? Everybody okay? So it comes up here, and this is on, this is on, this is on, right? So it's going to do what? Turn on the vacuum. Everybody okay? Vacuum on. Then what's thinking? Okay, so the vacuum's on. How does it know the vacuum is on? Because the little pressure switch says it's what? It's on, right? Okay. So then what's it going to do? Vacuum on. It's going to do what? It's going to retract this, right? How do it knows when it's retracted? Because this guy here goes true, right? Then what's it going to do? It's going to pick it up. Are we okay so far? How does it know it's up? It knows this guy's fully retracted, right? It knows there's still a part present, but this guy right here goes true now, right? Everybody okay? So what is it going to do? Feed cylinder retracted. How does it know that? So it's going to move it over to the side. Vacuum is still on, right? How does it know the vacuum is on? Because the pressure switch still says it is, right? Everybody okay? So what's it going to do now? Okay. So it's going to come up and it's going to, so now you can see this guy. So now it knows it's all the way on the right because of this sensor right here, right? Everybody okay? And so it's going to come up and do what? It's going to, okay. How does it know it's fully extended? Right? Okay. Then what's it going to do? Okay, on, right? It's going to do what? Turn the vacuum off. Then it's going to do what? It's going to retract. How do it knows it's retracted? Yeah, then what's it going to do? Okay, pickup, subtract, it's going to move over. How does it know it's over? Because of the sensor that it just covered up. And what's it doing now? Waiting on the next cycle. So what we did is we just stepped through a complete cycle, right? Everybody okay? So I really like this line. We can literally do what? We can put it in manual and press that green button. Every time we press the green button, it's going to do one step, right? Everybody okay? I close the door. So automated systems are basically sequence controls. So it goes through its sequence and then it ends up where it started out, right? Everybody okay there? And then it just keeps doing what? The same sequence over and over and over. We've already talked about this, the three things that make up a control system. We have input, we have the program or the logic, and then sooner or later we're going to do what? Generate outputs. Everybody okay? Step 1, cylinder, feed cylinder extends. Step 2, extend, picks up cylinder, switches on vacuum, right? Step 3, retracts. Step 4, retracts the pickup cylinder, extends the linear traverse cylinder, which is the top robot, extends the pickup cylinder, switches off the vacuum, retracts linear, and then what does it do? So this is the way it's happening, push button, right? So your start button is pressed, PLC picks it up, right? DJ, cylinder extends, PLC runs logic, does this, extends, PLC logic, does this. So this is the sequence, and when it hits the next step, sorry, we still got some more steps. Okay. So this is the actual function chart. This is the first thing that we're going to look at. So notice this thing has what? 6 steps. Now to get into it right here, this says this is what we need to have. It says input 1, 0, which is 4B1, has to be and B1 and, so the little up arrow means and, right? So it means they all have to be what? True, right? And B1 and 2B1 and 3B1 and 1B1. If all these are true, then it'll go into what? Step 1, right? Does that make sense? So what does it do during step 1? Well, what it's going to do is going to turn on output Q4.5, which is going to cause what to happen? Okay, and how does it know? What effect does this have? Well, 1B2 should become what? True. Everybody okay? This makes sense. Now down here, this says this is what's required to get into the next step. Well, what you notice, what this guy affected was what's required to get into the next step. So 1B2, which is hooked up to input 1.3, and we'll show y'all that. If it's true, then it falls into step 2. Step 2 is going to output Q4.6, which is going to cause what to happen? It's going to call this the extend, which is going to affect what? 3B2. If 3B2 is okay, then it's going to fall down into step 3. Step 3 is going to turn on what? Q53, which is going to turn on the vacuum generator, right? You understand? Which is going to affect what? 2P1, which is the vacuum pressure switch. If the vacuum pressure switch says it's okay, then it's going to fall into step 4, and it's going to call it to do what? Retract the feed cylinder, which is going to affect what? 1B1. Everybody follow me so far? If 1B1 is true, it's going to start into step 5, which is going to turn on Q4.7, which is going to cause what? Retract the cylinder, right? That makes sense. Everybody okay? Of course, they run out of room, so they put some dots down here indicating it's going to continue on the next page. When we go to the next page, we'll look for the number 1, and we'll look for the what? Number 2, right? Everybody okay? This makes sense so far. So we got into step 6. So to get into step 6, then 3B1 has to be true. 3B1 is true, then it's going to turn on Q5.6, which is going to cause what to happen? It's going to extend the traverse cylinder, which is actuator 4A. And how does it know it's extended? It's going to activate 4B2, right? Now follow me so good. If 4B2 is okay, we're going to move into step 7, which means what? Q46 should turn on, which should cause the pickup cylinder to extend, which is actuator 3A, right? You understand that? which is, how does it know it's extended? 3B2 will become true, right? Everybody follow this. If 3B2 is true, then this is going to get us into step A. It's going to turn on output Q5.4, which should turn what? Generator off. How do we know? How does it know it's off? 2P1 says it's turned off now, right? You understand? And then it comes back in here. If the pressure's turned, if the vacuum's turned off, we'll fall into step 9. Q4.7 is going to cause the cylinder to do what? To retract. How does it know it's retracted? 3B1, right? You understand? If 3B1 is okay, it's going to hit step 10. It's going to retract the traverse cylinder, which is 4A, so it's going to move back over to the left. How does it know it's on the left? 4B1 becomes true, right? And then it does what? Then it goes back up to here, right? That makes sense? And if we got it on single, if we got it on auto, the start should be true automatically, right? You understand? If we don't have it on start, if we don't have it on auto, then it's going to take all this stuff up here again, right? It's got to be all true, and then you got to press the what? Start button, which is what you're going to have to do for manual every. So guys, this is function chart. So I got this thing down here, and the pickup cylinder. This, like I said, the first time I taught this class, and we put a bug in the problem. Guess what the guys did? The guys started all the way up at the very top. Is that where you're supposed to start at? You're supposed to find where it stops and then figure what's required to cause it to do it, right? You understand? So let's say this guy right here did not retract. Well, you'll figure out why 1B1 didn't go true, right? You understand? Why didn't this go true? Well, it might be that this guy here never retracted, right? You understand? Or something's wrong with that sensor. And that's the beauty of these function charts, is you don't have to check the thing that you know it's what? Good. How do you know they're good? Because it got all the way down to it stopped on step 5. So I'm down at step 5. I'm not doing step 1. I'm not doing step 2 because it couldn't have got down to step 5 unless step 1 was what? Okay, right? Step 3 had to be okay. Step 4 had to be, we don't know, because it didn't get into step 5. But right off the bat, if you have these function charts set up for your module, for that section of the line, you should be able to go directly to what? To the problem. And that's what we're doing. That's what they're trying to do, is to set these charts up. So of course, all these charts are available. They're available in this book, right? These books right here. Guess what you're not going to have? You're not going to have these books. So what you're going to try to do, you're going to try to develop a function chart for one of these walls. Because let's say you got out to a plant and they didn't have these things. Well, if I was on up in the upper echelon, then I would do them right off the wall, right off the bat, instead of these guys going around there trying to figure out what's wrong. Let the line tell you what's wrong, right? You understand? But you have to understand the sequence. Well, the problem is, if you hadn't worked on that module, now I can understand if you have one section of the line that you're the only one that you work on, then probably you don't need these things. Because why? Because you know that section. You know the secret. But if you're working in maintenance down at Mercedes, and by George, you got to do what? You got to understand the whole thing, right? You understand? So these guys right here are basically step charts. So let's go back over there, guys, and we'll see if we can get the line working. So it looks like some of y'all did not check for alignment, so it looks like we're probably going to have some jams over there. How do you check? How do you know that sucker is perfectly aligned? As close as we can do. What would y'all look at? All right.
You mean all of the
So this is the information that we get with our manufacturing line. I think I have this all put together though, guys. I think. No. We get an overview, and of course it gives us a picture of the station. Come on. Well, what we're going to provide with y'all, one thing that I like about the Festo line is the Festo line actually labels all the sensors. So they've got the Amatro line doesn't label the sensors.
Some of the same sensors that I see on the, that you saw in the Festo line, I see the same numbers on the Amtron line.
Well, it's not the same. It's the same numbering system. So that's a standard numbering system when you set up a circuit like that. So we got the B's indicate they're what? Sensors, right, or proximity sensors. A means they're what? I'm guessing now. So just about every circuit on the Amatro line and the Festo line, its function in life is to run an actuator. Because what does the actuator do for it? Yeah, it changes energy into motion. Of course, we got two forms of energy. What's our two forms of energy over there? Pneumatic and electrical, right? Those are two forms of energy. So what they do provide it, and I've ran these off, so depending on which section of the line you get on, and we're not going to work on 5 because that's the robot section, is that I've ran these off individually. So what's these pictures right here going to do for you? The sensors are and how they're labeled, right? Because you know when you do your function chart, that's what you're looking at. So you go over there, you figure out what sensors are true before you press the what the first time, that start button. And then that's what's going to be required to get into your first step, right? You understand that? That makes sense? So we have these for each section of the line where you can come in and you can identify what sensors you have. But these guys, so these are pneumatic diagrams. So these are some that we've already looked at, right? So this is standard. So if I was to bring up the one for the Festo line, it would almost be identical to this. Because just about every circuit is in there to run an actuator. And either the actuators are going to be electrical or they're going to be what? Pneumatic. They're predominantly pneumatic. So the way it starts off, we have our service unit. This is called 0, right? Then from then on, this right here would be the first circuit. This is a directional control valve. What's M? M is solenoids. So M is a solenoid. So this is solenoid actuated spring returned, right? What's V? Valve, right? And this is very important, of course, that you know this because these are the way a standard print should be laid out. Top to bottom, right? You understand, right to left. And it should be laid out basically the way the line is. So I know my first actuator is going to be on the left, right? You understand? The last actuator should be on the right, toward the right. That makes sense? So this is a Word document. I was looking for my PowerPoint. Yeah, I was trying to write on it. I can, but it's hard to do with the recording software. So this is a directional control valve, right? And what's this symbol right here? A little white thing sticking up there. Manual override. So every one of these we can do a manual override on, right? You understand that? And then we even have those on our relay. These are unidirectional flow control valves, which means they only flow, and we're doing what we call meter out, which means, and you can tell by looking at the check valve. So this is called a check valve. The check valve is basically only lets the fluid flow in one direction. And if that arrow was pointing up, that would be meter in, but the arrow is pointing out, so this is what we call meter out. What does meter out mean? We talked about that the other day. So the problem we have with pneumatics is if I was to come over here and push on that side, what's the air going to do as soon as the cylinder moves? It's going to uncompress, right? You understand? So what would happen? It would be always jerky. So what we do is we control the flow of the exhaust, not the pressure of the exhaust. So now that sucker's always pushing against something, right? So the flow control is trying to keep the flow from flowing, right? You understand? Your pressure's trying to push it. So what happens is you always work against the pressure back pressure. And we call this meter out, and you can tell by these check valves, notice the arrows are pointing away from the cylinder. If they were pointing toward it, it means we would meter in. Now, normally on pneumatics, we meter out. And why is that? If we can. Single acting cylinders, guys, we got one option on a single acting cylinder, and that's the meter in. But we got a spring giving back pressure on the single acting cylinder, right? You understand? So it's working against the spring. But on your double action cylinders, what we do is on pneumatics is we meter out. And on hydraulics, it don't make any difference because hydraulics don't uncompress, right? You understand that? But the saying is, when in doubt, meter out. Meter out works on both of them. So instead of me metering in on hydraulics and metering out on my pneumatic system, odds are I would meter in all the way. And that way all my people would know how to put these unidirectional check flow control valves in there, right? Y'all know what we mean by unidirectional? Yeah, only one way. So what happens is when we put pressure out this one, it opens up the check valve and comes over and pushes this back over here. The exhaust comes over. The check valve closes and causes it to go to the flow control. So it only controls the flow in one direction, right? And then we use two of them, right? So we can control a double acting cylinder in both directions. So notice here they're using meter out on all of these. What's the little cradle right there mean? Magnetic. So they got magnets in them. So either our Hall effect or our reed switches can pick that up, right? Okay. And this is a rodded cylinder right here. That's that traverse cylinder that's rodded. So we got pneumatics, we got electrical. Of course, the electrical is going to give us the actual way the PLCs are lined up. I think this is this one. I get them confused every time. No, this actually shows us what IOs are assigned. So I want the other one. Yeah, but we don't normally put these manuals up, especially while we're doing this lab right here. And why is that? Because you would look at these function charts. These function charts are in there. The step charts are in there. What we're trying to do, and guys, these guys don't have to be right? So understand, what we're trying to do is just give you the experience of trying to develop these things in case you got somewhere it that didn't have them. And now you got an idea of how to develop them. And some of them are complicated, guys, because some of them have different paths it could go depending on what happens, right? And so you have a loop. You come up here and you decide which way it's going to go. So let me find my PowerPoint. trying to find my bump out. Well, we're going to be in lab. I mean, is there some reason you have to leave every class early? Every class. Last time you told me, but you didn't leave. Well, yeah, you need to make appointments with her when you're out of class. So what we would do if we had a section is we would come down here and we split it up, and then we come down to flow charts, right? And then you would put what's required to make it do what. So here it might be 1B2 is false, right? And over here it might be 1B2 is true. And if it's false, I think we put an overline or underline, I can't remember. And then that way you can actually indicate that your function chart goes two different directions, right? But eventually they're going to do what? Eventually they're going to merge back up, guys, because they got to do what? And they got to come back up to the start, right? I understand that. That makes sense. So if you look at the conveyor belt, if it's metal, it goes one way, right? You understand? If it's ceramic, it does what? It goes another. It gets a different cylinder. So that's the way you would split it up into two directions. Steps go across the top, right? If this will load. It says it's open somewhere. Oh no, this is not one. So the actuators move between the steps, right? And that's basically kind of different from the function chart. So the function chart, the actuators move in a step, right? You understand? And then we put what's required to go through that. But a step chart, and we don't have step charts for the Festo line. So one day we're going to try to do that. So this is the step chart for the pick and place section.
So it starts at that first one that starts track.
Well, no, not yet. What we do is this is what's required. So what has to happen? 1B1 indicates that it's what? It's retracted, right? You understand? 2B1 says I don't have pressure. 3B1 says this guy's retracted. And 4B1 says this guy's what? Retracted. Now, if all that's true, then what can it do? Then it can move to the next step. So it moves to this step right here. And then we're at a step. So what should happen so 1B2 should go what? Yeah, 1B2 should go true, indicating if this is extended, right? You understand? And it's also going to affect this down here. So 1B2 is affecting two different things. And that's what this little squiggly line means. It means not only does it affect this guy, it's all going to tell this guy can do what? He can do something, right? You understand? This guy hadn't done anything yet. It's at its original position, but it's fixing to do something, right? It will extend. It's not extended yet. It will extend. So what the steps are is shows you all the condition of all your sensors before it moves to the next step, right? This is why it's called a step chart. So between steps, this is where all your actuators are doing something. This is where your vacuum generator might be turning on. So what we're doing is we're seeing what's required. So right here, what's required to get this thing started?
1B1.
Has to be true, indicating it's what?
Retracted.
It's retracted, right? The parts feed cylinder. The vacuum, the 2P1 indicates the vacuum is turned off, right? 3B1 indicates what? That the pickup cylinder is retracted. And 4B1 indicates that the traverse cylinder is retracted, which is on the left side, right? You understand? If all that's true, then what's going to happen? Then it's going to move. So what's going to happen? Well, this guy here is going to extend. What else happens? Nothing happens. Just one thing. This guy right here did what? This extended. That's the only thing that happened. So the parts guy did what? Fed this guy out, right? You understand that? Okay. Now what happens? Well, 1B2 becomes what? True. 1B1 becomes false. 1B1 is also going to affect this guy right here, right? You understand that? And 4B1 is still what? False. Okay, if all that's okay, then what's going to happen? This guy's not going to do anything. Well, what's going to happen? This guy's going to do what? He's going to extend between the steps. So the steps is telling you what sensors are affected, and then all your actuators are moving between the steps, right? You understand? So what happened between this step? Well, this guy, the only thing that happened is this guy here did what? It extended. How does it know it's extended? Well, 3B2 went true. And 3B2 also is going to affect this guy on the next step. Can y'all see the little arrow? Okay. So then what happens? Well, this guy right here stays extended. This guy right here is going to turn on the what? The vacuum. How does it know the vacuum's on? 2B1, right? You understand? And it's also going to affect this step up here, step 4.
Tell me about that arrow. That arrow is,
It indicates what else the sensor affects. So 2B1, 1B1 tells it it's extended, but this is the guy that it's using, right? You understand? So 2B2 says this is the guy that triggered 2B2. This guy depends on 2B2 before it does what? Before it does something, right? This guy triggered 1B1, but what does 1B1 affect? 1B1 affects this guy down here, right? That makes sense. This guy right here triggered 3B1, but what does 3B1 affect? It determines when this guy does what? When it is. So here, this is where what triggered the sensor. This is what, when it triggered, it caused it to happen, right? Or when it became true. Right? You understand? So when this guy right here did what? When it retracted, what did that cause to happen? Well, now this guy says, okay, this guy is true, so the next step, what's going to happen? This guy's going to change position, not this guy. Does that make sense? Yeah. So what happens, so I don't know if I said that right. So when this retracts, 1B2 becomes true. Well, what's 1B2 going to cause to happen? It moves down here. That's the so it's going to cause this guy right here to do what? It's going to cause it to extend between the steps. How does it know it's extended? Well, 3B2 is true, right? You understand? What does it trigger? Well, it comes up here and says, okay, I'm true because it's going to cause this guy to do what? It's going to cause the vacuum to turn on. How does it know the vacuum is on? 2B1 is triggered. Well, what's that going to affect? I follow this arrow up and it says, okay, it's going to affect this guy right here. So now this guy knows that the vacuum's on, so what's it going to do? It's going to retract. This is going to trigger 1B1. What does 1B1 affect? Come down here to this arrow right here, right, where it goes to. So that's going to cause what? That's going to cause the pickup cylinder to do what? It's going to cause it to retract, which is going to trigger 3B1. Well, what's 3B1 going to affect? Well, 3B1 is going to affect this guy down here, which is going to cause it to do what during the next step? It's going to cause, or between the step, it's going to cause this guy right here to extend, which is going to cause 4B2 to go true. When 4B2 goes through, what's going to happen? That's going to cause this guy to do what? It's going to cause it to extend, right? Y'all follow this. Between the steps. When it hits this step, what's that going to happen? Well, that's going to make 3B2 go through. 3B2 is going to affect what? This guy right here. Y'all follow that? Not yet. We're still at this step right here. Okay, you understand? Then what happens? Well, that causes us to move to step 9. So what's going to happen during step 9? 2P1 is going to turn off, right? You understand? Which is going to affect this guy right here. It's going to cause it to move to what? Step 10. So these guys that stay flat all along, it means they're what? They're just staying where they're at, right? You understand? So all these actuators right here. So once this guy right here retracts, how long is it going to stay retracted? Through step 6, through step 7, through step 9, step 11. Now when it hits step 11, what's it going to do? It's going to, so step 11, if you notice step 11 and step 1 are exactly the same. Everything's in the same position. And that's what it says here. It says 11 equals what? 1. So this guy starts off retracted. This guy, pressure starts off, right? This guy starts off retracted, and this guy right here starts off retracted, and what would it do now? It'd just start back over. So this guy is not the same as a function chart. So a function chart, what's required to go between the steps is between the steps, and then this shows you the effect, right? You understand? So the function chart, every one of those blocks is indicating one of these, where what happens, something happens, right? You understand? The step chart gives us an idea of what's required to cause the actuators to do what? To move. So if I said what happens at step 2, what happens at step 2? What happens at step 2? Becomes true, right? You understand? That's the only thing that happens at step 2. If I said what happens between step 2 and step 3, then what would we say? Well, we'd say 3A does what? 3A extends. So your actuators are moving between the steps, right? You understand? Each step it shows you what effect it has on each sensor.
3A or 3B1?
3A actuator. Actuator 3A extends. So when I said A, you know I wasn't talking about a sensor. I had to be talking about a what? Actuator. Now you're right, but 3A extends. So that's what's happening here. 2B1 is not true. What happens between step 2 and step 3? The pickup cylinder extends. And then once it's fully extended, it does what? It causes 3B2 to go to. And what does 3B2 affect? Well, 3B2 affects actuator 2A, right? You understand? So what's happening between the steps is what's going on with our actuator. This is what's required to cause it to do what? To cause it to move to the next step, right? You understand that? But what happens between the lines, inside the block, what's happening? This is when your actuator direction what? Moving. That makes sense? And these guys, which one do you prefer? Well, different people have different strokes for different folks, right? You understand? So if you have both of them available, then you choose the one that you're more comfortable with, right? You understand? Because both of them is going to help you go directly to the what. So what happens if it don't do step 6? You look at what needs to go. You look, okay, so what's got to be the problem? Well, probably 1B1's your problem, right? You understand? Because that's the only thing that's required for what? For us to move to step 6. Which is pretty neat, right? You understand? So that's what I like both of them. You know, I don't prefer one over the other, but when we were learning these up in Tennessee, every group had ones that they liked best. So, but what they did at that one, instead of doing what we're going to do, we're going to give y'all each a shot at making a function chart, right? And then we'll go over there. You'll present it to your class. And then we'll rotate around, and then we'll let y'all do a step chart. That makes sense? So that'll be while we'll be in lab, start a class, if everybody shows up. What you looking at, Joe?
No, you said being lab on Wednesday.
They'll be on lab almost every day.